are three important steps that you need to know when you're solving an absolute value equation. The first of these is that you want to isolate your absolute value term on one side of the equation. So in this case, I have 3x minus 1 absolute value minus 5 is equal to 0. Before I can start solving for this, I have to isolate this term on its own. And I'll do that by adding 5 to both sides of the equation. That gives me 3x minus 1 is equal to 5. So I've completed this first step, and now I'm ready to solve. The second step is to solve it twice. Once for the positive value and the second for the negative value solution. What I mean is 3x minus 1, take it out of the absolute value, can equal to 5, or 3x minus 1 can equal negative 5. Why? Because whether I put 5 or negative 5 in my original equation, I am still going to get a positive 5 out of it. So I have to make sure that both of my solutions represent the positive and negative numbers that go inside the absolute value. So in this case, 3x is equal to 6, x is equal to 2, or 3x is equal to negative 4, and x is equal to negative 4 over 3. These are the two solutions of the absolute value. But I'm not done yet, because the third step involves checking the solutions. And what you have to do is take your solution and plug it back into your original equation and check that it comes out as a true statement. So 3 times 2 minus 1 minus 5 is equal to 0. And notice that I'm using the original equation, not the one where I used isolated the absolute value, although you can, but the most accurate one is to use the very original equation you were given. So here I have 6 minus 1 minus 5 is equal to 0. 5 minus 5 is equal to 0. So this checks out. This is true. So 2 is a solution. Now let's see if negative 4 over 3 is a solution. 3 times negative 4 over 3 minus 1 minus 5 should also equal 0. Okay, so here the 3's cancel out. I have negative 4 minus 1, although I don't need the parentheses there, but I already wrote it. 5 is equal to 0. Negative 5 in absolute value minus 5 is equal to 0. Because when I take this out of the absolute value, I get 5 minus 5 is equal to 0. Okay, so here is another example of solving for an absolute value. And again, first thing I need to do is make sure that I isolate my absolute value term on one side of the equation. So I have a fraction here and I have a minus 2 here that I'm going to move everything to this side. And I will begin by multiplying everything by 2. This will cancel out and I am left with x plus 5 minus 2 is equal to negative 2x. Now I'm going to move this side over. I'll add 2 to both sides. X plus 5 is equal to negative 2x plus 2. Now I have my absolute value on its own. I'm ready to solve twice. And again, once for the positive value and once for the negative value, because both of these can be solutions, either or. Okay, so x plus 5 is equal to negative 2x plus 2. That's one solution. X plus 5 is equal to negative. Now here is where it might get tricky because you have to treat this whole term as one entity and you have to put a negative in front of it. So this whole term becomes negative. Put a negative sign here and you treat it for the whole term. Okay, so let's solve this one. I'll bring the 2 over here. I'll add 2x to both sides. This becomes 3x plus 5 is equal to 2. And then I will move my 5 over. 3x becomes negative 3. X is equal to negative 1. So this is one solution, but I don't know that for sure yet because I still have to check it in step 3. And let's solve this one. X plus 5 is equal to, the negative sign is going to distribute to all the terms. So this becomes positive 2x and this becomes negative 2. And again, I'm going to move my 2x over. This becomes negative x plus 5 is equal to negative 2. Move the 5 over. Negative x is equal to negative 7, or x is equal to 7. And the third step is to check my solutions and make sure that both of them are true solutions. So let's go back to our very original equation here. 1 over 2 absolute value negative 1 plus 5 minus 2 should equal to negative 1. Or in this case, actually, because I have a negative x here, right? So it would be negative 1. Because this is my x. X is equal to negative 1, and I had a negative here in the original equation. Alright, I'm running out of space here, but I'll try to make it work. 1 over 2, this becomes negative 1 plus 5 is 4, minus 2, this should give me 1, right? Because negative times negative is positive. Okay, let's move on to this side. 1 over 2 times 2 is indeed equal to 1. So this is a solution. Now let's check this one. Alright, so 1 over 2, in this case, my x is equal to 7 plus 5 minus 2 should equal to negative 7, right? Because my x here is negative x. So 1 over 2, 7 plus 5 is 12, minus 2 is equal to negative 7. I can see that this is not going to work out because 10 divided by 2 is 5, and 5 is not equal to 7. So 7 is actually not a solution. I cannot include this in my solution. X minus x is equal to negative 1 is the only solution in this case. So you can see that even though I have to solve twice, once for the positive value and once for the negative value of the absolute value, but that doesn't mean that both of them are true solutions. That is why step number 3, checking the solutions, is crucial.